Hello students, welcome to LearnGuru Classes. So today in this video, we are going to study Euclid's division algorithm under the first chapter, real numbers. So the first part of the video, we will be concentrating on some basic concepts like what is algorithm, what is HCF. After that, we will try to cover the main topic, that is Euclid's division algorithm. And I assure you that after watching the video, your concepts about Euclid's division algorithm will be very clear. So with this note, let's begin our class. Before understanding Euclid's division algorithm, one should know what is an algorithm. So algorithm is used for solving a certain type of problem with some well-defined steps. For example, you have an exam, okay, and you want to purchase a maths book, okay. So what you need to do to purchase the maths book, okay, you have to come out of the house, walk towards the bookstall, purchase the book, okay, and accordingly come back to your house and study. So what is the problem over here? You need maths book. And what is the solution? You have to get the book or you have to purchase the book. So the problem, that is you need a book, and the solution that you have to purchase the book, in between these two paths you have to go through certain well-defined steps to get the destination or to get the solution. So accordingly, algorithm is nothing but solution to certain problem following some well-defined steps. Now, why do we study Euclid's division algorithm? So, Euclid's division algorithm is basically used to find the HCF of two numbers. Okay, so we have already studied how to find out HCF of two numbers using conventional method. Okay, so now we are going to see how we can find out using Euclid's division algorithm. So first of all, we have to understand what is HCF, how to find HCF using conventional method, and use this concept to find out HCF using Euclid's division algorithm. Before going into Euclid's division algorithm, we should know what is highest common factor. So, before knowing highest common factor, you should know what is a common factor. So, if two or more numbers have the same numbers as their factor is called as common factor. And HCF is defined as the highest possible number which divides both the numbers completely. So, to have a clear understanding about common factor and highest common factor, let us try to understand it with the help of an example. Let's find out the HCF of 12 and 24. So let's write down here the number 12 and 24. So we are going to find out the HCF using conventional method. What are the pair of factors of 12? 1 into 12 is 12. 2 into 6 makes 12. 3 into 4 makes 12. Why is it called pair of factors? Because all these numbers 1, 12, 2, 6, 3, 4 are the factors of 12. Okay, so one combination of 1 and 12, that is the factors, makes 12. So for here this we call it as pair of factors. So what are the factors? Let us write down here 1, 2, 3, 4, 6 and 12 are the factors of 12. Pair of factors for 24, 1 into 24, 2 into 12, 3 into 8, 4 into 6. So, factors for 24 are 1, 2, 3, 4, 6, 8, 12 and 24. So the common factors are 1, 2, 3, 4, 6 and 12 are the common factors. So the highest common factor among all these factors, the highest common factor is 12. So the HCF of 12 and 24 is 12. The second example is find the HCF of 15 and 25. So let's write down 15 here, 25. Okay, so what are the pair of factors for 15? 1 into 15 makes 15. 3 into 5 also makes 15. So the possible factors of 15 are 1, 3, 5 and 15. What are the pair of factors for 25? 1 into 25 and 5 into 5. So the factors of 25 are 1, 5 and 25. Okay, so let's try to find out what are the common factors of 25. So the common factors of 25 are 1 and 5. So there are two common factors of 15 and 25, that is 1 and 5. So which one is the highest among all the factors? Of course 5. So the HCF is 5. Okay, so this is how we find out HCF of two numbers. Now you will be finding HCF of two numbers by using Euclid's division algorithm. So this is Euclid's division algorithm. So as already been told to you what is algorithm. Algorithm basically consists of a series of steps, okay, that helps you to find a solution to the problem. Okay, so let's try to read out each and every step of Euclid's division algorithm and try to analyze it with the help of example. So first one is, let A and B are two positive integers where A is greater than B. So the story starts from A and B are two positive integers and A is greater than B. Okay. Now first step is, on dividing A by B, we get the quotient Q and remainder R such that A equals to BQ plus R, where 0 less than equal to R less than B. So here, since A is greater than B, so A I can call it as dividend and B I can call as the divisor. Okay, so I will be doing A by B. So means I will be dividing A by B, and after dividing A by B, I will get Q as quotient and R as remainder. Okay, so the value of quotient can be anything and the value of the remainder can be anything. Now, there are two possible chances of the remainder. First is, remainder can be equal to 0 or remainder may not be equal to 0. But according to Euclid's division lemma, the value of the remainder should be less than the value of the divisor. Okay, everything will be clear when I will be taking an example. So according to Euclid's division lemma, this A equals to BQ plus R means if you multiply the divisor into quotient plus remainder will give you the dividend. Okay. So the second step is, if R equal to 0, so there are two possible values a remainder can have. Either it can be 0 or R not equal to 0. So if R equal to 0, then HCF A comma B equal to B, that is HCF will be equal to the value of the divisor. If R is not equal to 0, then apply the division lemma to B and R. Continue the process till the remainder is 0. Okay, so the last divisor will be the required HCF. Now let's try to take two examples, okay, and try to understand Euclid's division algorithm better. So I will take two two examples. So case 1, A equals to 24 and B equals to 6. Okay, so let me do A by B. Okay, so 24 by 6, 24. So 6 4s are 24. So the remainder comes as 0. So this is the remainder. Okay, and what is the dividend? Dividend A equal to 24 and the divisor B equal to 6. So as the remainder comes out to be 0, we can say that HCF of 24 and 6 is equal to the value of the divisor, that is 6. Okay, simply the value of the divisor will give me the value of the HCF. Okay, so this is a simple case. Okay, so let's try to understand what will happen if the remainder does not come out to be 0. So case 2, let's take, I will take A equals to 52 and B equals to 3. So A is acting as the dividend here and B equal to 3 is acting as the divisor. So I will do 52 divided by 3. So 52, 3 ones are 3, 22, 3 sevens are 21, remainder comes out to be 1. That is not equal to 0. Okay, so this is the value of the quotient, this is the value of the remainder. Okay, so if I apply Euclid's division lemma over here, BQ plus R, okay, so this will give me B value is 3, quotient value is 17 plus 1, it will give me 52. Okay, now you have to make the remainder to be 0. You will stop the process only when the remainder comes out to be 0. Since the remainder does not come out to be 0, so we will be repeating the step. At this particular step, what will we do? We will be dividing B by R. Means you will be dividing the divisor by the remainder. Okay, so B is here 3 and remainder is 1. So I will do 3 divided by 1. So if I do 1, 3 is a 3. So remainder comes out to be 0. Okay, so in this particular case, since the remainder comes out to be 0, so we can stop the process. Okay, and here the HCF of 52, 3 will be equal to the value of the divisor in the latest step. Okay, so here the divisor over here is 1 over here. So the value of the HCF will be 1. Okay, so I think the process is clear to you. Okay, we will try to solve it with some other examples. Let us try to solve the first sum using Euclid's division algorithm. Means using Euclid's division algorithm, find the HCF of 15 and 25. So we have already found out the HCF of 15 and 25 using the conventional method, and the HCF came out to be 15, 25 has come out to be 5. So let's check whether it is matching with the conventional method or not. So the first step of Euclid's division algorithm is that first work, you have to choose between the two numbers which one will be A and which one will be B. So since A is greater than B, so from this number evidently A will be 25 and B will be 15. So let's write down A equals to 25 and B is equal to 15. So we will write, since A is greater than B, we divide A by B. So 25 by 15. So we get 15 ones are 15. We get 10 as the remainder. So here quotient is Q and the remainder is R. Okay. So according to Euclid's division lemma, we can write A equals to BQ plus R, that is B is 15, quotient is 1 and remainder is 10. So it gives us 25. Okay. So here remainder has not come out to be 0. So since a remainder has not come out to be 0, so we have to go through some other steps to make the remainder as 0. So we have to go for repetitive division now. So what numbers we will take into consideration for the next division? Okay. So here the remainder is R and the divisor is B. Okay. So in the next step, you will be dividing the divisor by the remainder. Okay. So in the next step, since remainder R is not equal to 0, remainder you are getting as 10, it is not equal to 0. So what we take? We divide the last divisor, that is 15, by remainder, last divisor B, write down B, by remainder R, that is 10. Okay. So 15 divided by 10. So 10, 15. So 10 ones are 10, 5. So over here 10 is the divisor, 1 is the quotient and R is the remainder over here. Okay. So using the latest values that you have got, the value of B, Q, R and the dividend is of course A. So using these values you are to apply Euclid's division lemma. So according to Euclid's division lemma, we will write A equals to BQ plus R, that is B value is 10, quotient is 1 and remainder is 5. So 10 plus 5 gives us 15. So it is exactly matching with the dividend, that is 15. Okay. So here also we are not getting the remainder to be 0. So again we have to go to the next step. Okay. So what I will do, since R is not equal to 0, so we divide the divisor, that is, what is the divisor over here? 10. Okay, divisor of the latest step, that is 10 by the remainder. So remainder R is how much? 5. Okay, so I do 10 by 5. So if I do 5 2s are 10, so this is 0. So over here 2 is the quotient, R is the remainder, 5 is the divisor and 10 is the dividend. So the HCF, so as remainder came out to be 0, so according to Euclid's division lemma, I can write A equals to BQ plus R, where B is how much? 5 and Q is how much? 2 and the remainder is 0. So 10, exactly 10 is the dividend over here. So the HCF of the two numbers 15 and 25 will be the value of the latest divisor, that is 5. So the value of the divisor is 5 over here. So HCF of 15 and 25 is 5, which is exactly matching with the conventional method. Okay, so this is just an easy example that I have taken. So let's try to solve another two sums. The next example of using division, the next example is using Euclid's division algorithm, find the HCF of 867 and 255. So which one will be A and which one will be B? Of course, since 867 is greater than 255, so we will be choosing 867 as A and B as 255. So let's write down A equals to 867 and B equals to 255. So since A, first step is, since A is greater than B, we divide A by B. Okay, so 867 by 255. So obviously A is called the dividend and 255 or B is called as the divisor. So let's perform the division. So 255 into 3 gives us 765. Okay, so let's subtract it. It will be 201. Okay, so the quotient comes as 3 and the remainder comes as R. And the remainder, that is 102, is less than the divisor, that is 255. Okay, so we can easily apply Euclid's division lemma over here. And this is A. So according to Euclid's division lemma, we can write A equals to BQ plus R, where B is 255 into 3 plus R is 102. Okay, so this will give me the value of 867, which is equal to A. So since the remainder has not come out to be 0, so we have to follow some other steps. Okay, so in the second step we will write, since R, that is not equal to 0, so we divide the divisor that we have obtained in the latest step, that is 255. We divide the divisor B, that is 255, by the remainder R, that is 102. Okay, so let's perform the division. 255 by 102. So 255 by 102, 102 into 2 gives us 204. So 51. So over here Q is the quotient, R is the remainder and B is the latest divisor and A is the dividend, that is 255. So according to Euclid's division lemma, we can write A equals to BQ plus R, where B is 102 into 2 plus 51. That is 204 plus 51 gives us exactly 255. Okay. So over here remainder is coming out to be 51. So the remainder is not 0. So it's obvious that you have to go through the second division or few other repetitive divisions to get the remainder as 0. So the third step, since the remainder, that is 51, is not equal to 0, so we divide the latest divisor. Okay, you are not going to divide 255 by this. Okay, the latest divisor of it. So latest divisor is 102. So we divide the divisor B, that is 102, by the remainder R, that is 51. Okay, so 102 by 51 gives us 51 to 102. Remainder comes out to be 0. So this is the quotient, this is the remainder, this is the divisor, this is the dividend. So remainder came out to be 0. So we can stop the process here. So before that we have to apply Euclid's division lemma. So according to Euclid's division lemma, we can write A equals to BQ plus R. So 51 into 2 plus 0. So 102. Okay. So since remainder came out to be 0, so the HCF of 867 and 255 will be equal to the value of the latest divisor, that is 51. So HCF of 867 and 255 gives us 51. Okay. So let's try to understand it with the help of the second example. The next example is if the HCF of 65 and 117 can be written as 65m minus 117, find the value of m. Means what? You want to find out the HCF of these two numbers, okay, and whatever value you have got after finding out the HCF of 65 and 117, that will be equal to this number, and from that equation you have to find out the value of m. Okay, so let's try to find out the HCF first. So before that, step 1, you are to choose the value of A and B. So A is greater than B, so A will be 117 and B will be equal to 65. So since A is greater than B, so we divide A by B. Okay, so A 117 by 65, that is 117. So 65 ones are 65. So you are getting 252 as the. So here A 117 is the dividend, 65 is the divisor, Q is the quotient, and R is the remainder. So according to Euclid's division lemma, we will write A equals to BQ plus R, where B is 65 into 1 plus 52, so that is 170, which is equal to A. So the remainder is not coming out to be 0. So in the step 2, since R is not equal to 0, we divide B by R. That is, B value is 65 and R value is 52. So 65 by 52. So 52 ones are 52. So you are getting 30. So over here 65 is the dividend, 52 is the divisor, 1 is the quotient and R is the remainder. So using the latest values, we will find out the value from Euclid's division lemma. Euclid's division lemma. We will write A equals to BQ plus R. So 52 into 1 plus 13, that is, it will give us 65, that is equal to A. Okay, so now remainder has come out to be 13, that is not equal to 0. So step 3, since R is not equal to 0, we divide the divisor. So divisor over here is 52 by the remainder. Remainder comes out to be 13. So 52 divided by 13. So 13 fours are 52. Remainder comes out to be 0 over here. Okay, so we can stop the process then and there itself. Okay, so what will be the HCF of 117 and 65? It will be equal to the latest divisor. That is, 13 is the latest divisor, 52 is the dividend, 4 is the quotient and R is the remainder. Okay, of course, according to Euclid's division lemma, we can write A equals to BQ plus R. So B is 30 into 4 plus of 0, so 52. So the HCF of 170 and 65 will be the value of the latest divisor, that is 13. Okay, so once we got the value of HCF as 13, so this value we are going to use over here, because it is said that if the HCF of 65 and 117 can be written as 65 and minus 117. So, and you are getting the HCF as 13. So let us equate these two values. 117 equals to 13. So 65m 117 plus 13. So this is 130. So m is 130 by 65. That is the value of m is 2. Okay. So this is how we solve the sums, that is finding out HCF using Euclid's division algorithm. This is all about Euclid's division algorithm. I hope that you have understood the concepts that I have tried to explain to you. So if you like this video, please subscribe to LearnGuru Classes, like, comment and share it with your friends, family and relatives. So stay tuned for more quality and varieties of content. Thank you so much. Bye-bye.